10.5, the Pythagorean theorem. So the objective of this lesson, we're going to learn how to solve problems using the Pythagorean theorem, hence the name. And we're going to use Pythagorean theorem has to do with right triangles, and we're going to use Pythagorean theorem to tell whether a triangle is a right triangle or not. We'll talk more about what a right triangle is in a second. So the Pythagorean theorem has to do with right triangles. So let's talk about what a right triangle is. So right triangle. A right triangle is a triangle that has one angle, that is 90 degrees or right. The side opposite that right angle is called the hypotenuse. It's the longest side. The way angles and sides work is that the biggest angle gets the longest side, the smallest angle gets the smallest side. Now the hypotenuse is always going to be in a right triangle, 90 is the biggest angle, so that hypotenuse is always going to be the biggest side. We always label hypotenuse C. Always. So hypotenuse is always C. These two sides of the legs, they don't matter. One of them is A, one of them is B, doesn't matter. BA, AB does not matter at all. So they're called the legs. A and B. Again, it does not matter which one's first. So that's a right triangle. And in a right triangle, we have this formula called the Pythagorean theorem. Very famous formula. It only works for right triangles. Pythagorean was a great mathematician back in his, and his formula, his theorem is this one. If you take the two sides, the two legs of a right triangle, so like A here and B here, remember the legs do not matter which one's which, as long as they're smaller ones, and you square them, you add them up, it's going to equal the third side, the longest side, the hypotenuse, which is always C, squared. The square of the two sides of a right triangle are always equal to the square of the remaining side. That's the Pythagorean theorem. And we're going to use it to solve things. So like right here, we're going to use it to find the missing length of each one of these. Now notice it's a right triangle, so I could use the Pythagorean theorem. A and B are the two legs. I don't care which one's which. Just keep in mind that this is the right angle, so this is the hypotenuse. That should always be C, which it is in this case. And then these are the two legs. Just name one of them A, one of them B. Does not matter. Put down the Pythagorean theorem. A squared plus B squared equals C squared. One of my favorites. You just plug it in. So you substitute these numbers in for the variable. So 6 squared plus 8 squared equals C squared. So squared. 6 squared is 36. 8 squared is 64. 36 plus 64 is 100. Equals C squared. You square root it. You should get plus and minus 10, but we're doing a triangle, so we don't care about the negative. So C just equals 10. That's actually a very famous right triangle. 6, 8, 10 is one of the famous ones. Let's look at the next one. So first thing I'm going to do is figure out the hypotenuse. So here's the right angle, so here's the hypotenuse. That is C, that is the most important part. Because A and B don't matter. That's A, this must be B. So we can set it up, right? A squared plus B squared equals C squared. A squared plus 12 squared equals 16 squared. A squared plus 144 equals 256. You can use a calculator. Subtract 144 from both sides. I get A squared equals 112. Square root of that. I do not know what the square root of 112 is. Doesn't work out nicely, so I'm going to prime factor. I'm going to break it down real quick. So 2, I always like to start small, and that would be 56. 2 and 28. 2 and 14. And 2 and 7. I have a pair of 2's and a pair of 2's. Remember, when they both come out, they're going to be multiplied. So I get 4 rad 7. So that's what A is. A is 4 rad 7. Alright, so don't forget, we can't leave it at 112. We want to simplify that. Simplify that and it gets 4 rad 7. Now let's do it with an application problem, kind of. A real world example, as I like to say. So the sail of a keel boat, I don't know what a keel boat is, forms a right triangle as shown from the height of the sail. So here's the thing. I don't have to know what a keel boat is. That wasn't born in money. Right here, you just have the picture. There we go. There's a triangle that we need. A little right triangle right there if you can't tell. Alright, this is h, and this is 10, that's 20. That's all I need. Gotta label my side real quick. First guy find the hypotenuse, that's this guy. That's my c. A and b don't matter. Even if it's an h, we'll leave that h right there. Say a and b. Use my formula, a squared plus b squared equals c squared. Substitute things in, so I get 10 squared plus h squared. I know I mixed it up, but it doesn't matter. C is the only thing that matters. It's 20 squared, so I get 100 plus h squared equals 400. Subtract that, get h squared equals 300. Square root. Now, in this case, it's an application problem, kind of. So you use your calculator. I'm always fine using a calculator on application problems. I'm going to break it down because this is practice. So I'm breaking down 300. I'm going to start slow. Let's go 2 and 150. And then 2 and 75. And then like 5 and, that's 25 after, so 15. And 5 and 3. A pair of 2s, a pair of 5s. So I'm going to get 2 times 5 on the outside. And 3 left over. So 10 rad 3. That's the height of that sail that I cannot afford. Okay, next one. Now let's use the converse of Pythagorean. Converse means let's use it backwards. So what does that mean? I'm going to give you 3 numbers. Something like 1, 2, and 3, or 6, 8, 10. Now I want you to tell me if they're a right triangle or not. Now how do we do that? We're just going to use our famous formula. Pythagorean theorem. If the Pythagorean theorem works, if a squared plus b squared equals c squared, like here, then it's a right triangle. If it doesn't work, like I say right now, this one doesn't work. A squared plus b squared not equal c squared. By the way, c is always the biggest number, right? So c would be here, and c would be here. It's an easy way to check if it's a right triangle or not. If it doesn't work, then it's not a right triangle. That says not. There you go. That's all it is. We're going to use Pythagorean inverse. If the Pythagorean holds, we like to say, then it's a right triangle. If it doesn't hold, it's not a right triangle. So let's do a couple examples. So I want to know whether this is the right triangle or not. So first thing I want to do is figure out the biggest side. 16. That's my C. So A and B don't matter, whatever. Whatever wants to be A, whatever wants to be, doesn't care. Let's see if this holds. 9 squared plus 12 squared, does that equal 16 squared? So 9 squared is 81, that's 144, and 16 is 256. I add that, I get 5, 8 and 12 is 12. 225, that does not equal 256, so not a right triangle. And it's that simple. Let's try the next one. So same concept. First one, figure out what the biggest one is. In this case, that's that one. That's our C. So we're going to do 28 squared, A squared plus B squared equals C squared. Plus 45 squared. We're going to see if that equals 53 squared. So I don't know what 28 squared is. I'm going to use my calculator. So I'm not crazy. 28 squared plus 45 squared equals 2,809. Let's go with 53 squared. I think it's the same thing. That is, yeah, 2,809. So that equals that one. So this means it is a right triangle. Okay, let's quickly do a couple application problems and then we're out of here. Truck. Violetta needs to construct a ramp to roll a cart onto moving boxes from her garage into the back of her truck while she's moving. How long does the ramp have to be? So you have a little picture here. Again, if you notice there's a triangle right there, that's all I need. Who cares about the pictures? It's a story. So that's my right triangle. It looks like the height right here is 36. And that is 6. So you're trying to decide, is it this or this? That's the length from here to here. So that's the base. The base is 6. So what we're missing, I guess they all tell you that she needs a ramp. That's what we're looking for. So that goes right there. So we're missing hypotenuse, right? That's my C. So use our formula. A squared plus B squared equals C squared. So 6 squared, again, these two legs don't matter. One of them is one of them. equals c squared. I'm going to again use my calculator because, yes, I suck at that type of math. I'm actually pretty good at it, but I don't like to, that's going to be kind of hard. And you get this, 1332 equals c squared. Then we're going to square root of that. Take the square root of that. I feel like that's what I should know. I should know the square root of 1332. I'm going to be annoyed when I see the answer. Then we take the square root of our answer. Here's a little hint. You can just press up the answer there. Okay, 36.49 blah blah blah. So I guess I should have known. I feel better about myself now. So C equals, now here's the thing. See how it's a decimal? So we're going to approximate the answer. When we approximate the answer, you don't want to put equals because that means it equals the answer. You want to put a little approximation sign. A little curvy equal sign. That means approximately. So we could round it. So it's 36 point, so I'm going to go to the nearest tenth. 0.5. So C is approximately 36.5. Last one. A right triangle has one leg that is 8 inches shorter than the other leg. The hypotenuse is 30 inches long. Find the length of each leg. Ooh, this is fun. So hypotenuse is 30 inches long. A triangle has one leg that is 8 inches shorter than the other leg. So this is a trick to that. Let one leg be x. The other one is 8 inches shorter, so the other one's 8 minus x. I gotta solve this. So we're gonna use our formula. A squared plus b squared equals c squared. Remember, this is my c, the hypotenuse. So I'm gonna sub these guys in. X squared plus x minus 8 squared equals 30 squared. Oof, luckily we're honors. So we gotta simplify this. Now here's the key thing about this. I've said this so many times. X minus 8 squared is not x squared minus 64. Please do not give me that. Yes, actually, this means multiply it by itself. Yes, you have to actually do that. So I get x squared minus 8x minus 8x plus 64. So I get x squared minus 16x plus 64. If you just squared both sides, you would lose this middle term right there. So this is x squared. This guy is x squared minus 16x plus 64, and it equals 30. So I get 2x squared minus 16x plus 64 equals 30. And remember the way we solve this? You have lots of options. Quadratic formula, complete the square, factoring, anything you want to do. I'm going to subtract 30 from both sides. I'm going to go the factor slash quadratic formula route. Plus 34. 0. The first thing I hope is that if you notice, these are all even. Let's make our life easy. Let's divide everything by 2. Everything. If you divide one side by 2, you divide the other side by 2. So I'm going to get x squared minus 8x plus 17 equals 0. Hopefully that factors. I need two things that multiply to get 17, but add to get 8. I'm not sure if that's anything. Man, let's try to use the quadratic formula now. Or complete the square. Let's complete the square. So I'm going to complete the square. Move this to get this by itself. X squared minus 8x equals negative 17. And then we're going to get the middle term divided by 2 and square it. So 16. I'm going to add 16 to this side. I got to add 16 to that side. So I get x squared minus 8x plus 16 equals 0. Equals, sorry, 1, negative 1. What was I thinking? Anyway, that always factors perfectly. It's always a thing before you square it. So in this case, it's x minus 4 squared equals negative 1. Try to square root it. Any good imaginary numbers you can't do, so no solution. Yay, all that works for that. Anyway, valid answer, no solution. And that's that.